Greetings, Professor. I'm Umesh from EC. I'm doing a project on extraction of fingerprint minutiae for fingerprint recognition using MATLAB. I thought this PPT template would be apt for my topic, which is related to fingerprint recognition, hence I chose this template. Let me start with explaining a small incident. One day, while my friend was sitting beside me, I logged into my Facebook account. He saw my password. He then logged into my account without my notice and he played pranks on me. I then had to log into my Facebook account and change the password. So then I realized that these traditional methods like pins and passwords are not at all reliable. There are chances that these passwords can be stolen by a fraudulent imposter. Apart from that, you may even forget your own password because you have different passwords for different accounts. So this is where biometrics come into picture. Biometrics make use of human attributes and characteristics for personal identification and authentication. Fingerprint recognition is the most reliable and accurate recognition system among all the biometrics. It is also the most widely used one. So these are some of the important terms used in this project, which are so basic. So let me start with defining minutiae. Minutiae are nothing but the areas having local ridge characteristics and occurring at a ridge ending or a ridge bifurcation place. Let me show you this in this figure. These are the ridge endings and ridge bifurcation points. So ridge ending is basically the place where the ridge ends, and ridge bifurcation is the place where the ridge divides into two. So all these points are minutiae points. So differentiating feature between two fingerprints is minutiae. So you and your friend have different minutiae. There is no chance that you and a different person in this world have same minutiae. So that is how you authenticate the personal identity. Ridge ending is where the ridge ends abruptly, as I explained to you, and ridge bifurcation also I explained already. So this is the figure. Coming to the topic, biometrics. Biometrics is the form of science involving identification of individuals and access control using human body characteristics like fingerprints, retina detection, and speech recognition. Of all these methods, fingerprint recognition is the major form of biometrics which is widely used, which is also most reliable. It is used in many organizations like banks, hospitals, business organizations, and so on. Sorry for the spelling mistake. Telecommunications, etc. These are reliable and efficient among all the other methods. So, when coming to the fingerprint recognition system, there are three stages. The first one is extraction of minutiae, the second one is evaluation of the extracted minutiae, and the third one is the comparing the extracted minutiae with the database of fingerprints to find the correct match. So this project actually deals only with the extraction of minutiae, which is the most crucial step in the fingerprint recognition system. But there are some challenges extracting the minutiae. The first one is noise. There is noise and the fingerprints are not clear sometimes. Most of the times they're not clear. When a person puts his finger for scanning, they may not be clear and there'll be some noise and they may not be perfectly scanned. Deficiency of contrast, the images might get blurred and they may not be clearly seen. So all these are problems while extracting the minutiae. So what's the goal of this project? The goal of this project is to accurately and efficiently extract the minutiae in spite of all these problems like noise, deficiency of contrast, blurring and all. So how do you achieve this? So how do you achieve the minutiae extraction? So before extracting the minutiae, you have to enhance the image. Enhancing is improving the image without any blurs to make it clear, so that when you extract the parameters like minutiae, they'll be accurately extracted. So image enhancement enhances the clarity of the structures like ridges and valleys of the input fingerprint images. So the main basis for this technique is the frequency and orientation of the fingerprint ridges, how the fingerprint ridges are oriented and how the frequency is calculated. So for this project, there's a system design which consists of three major blocks. The first one is sensor, which captures the data. could be any kind of sensor, optical sensor, semiconductor sensor, any kind of sensor. And the second one is minutiae extractor, which is what this project actually deals with. And the third one is minutiae matcher, which is beyond the scope of this project, but I'll explain you what basically that means. Minutiae matcher tests the database consisting of a large number of fingerprints for a particular fingerprint to find the correct match. So, to accommodate all the worst case conditions and pessimistic scenarios, our testing database consists of scanned fingerprints using the ink and paper method. This way, no matter how bad the images are, there is a very high possibility that the match is found. So this is the block diagram of the system, which I previously explained. Sensor, minutiae extractor, and minutiae matcher. The sensor first extracts data, then sends to a minutiae extractor. Sensor actually captures the data, which sends to minutiae extractor, which then extracts the minutiae, and then these minutiae are searched in the database by the minutiae matcher for the correct match. So minutiae extractor. There are three stages in minutiae extractor, which are pre-processing, minutiae extraction, and post-processing. So pre-processing has two stages again, which is image enhancement and image binarization, and minutiae extraction again has two stages, which is thinning and minutiae detection. I'll be explaining the terms later in the presentation. Post-processing is removal of the false minutiae, which are basically not used for the extraction and matching, which are redundant. So pre-processing is actually an image enhancement. Pre-processing is what you do before the actual process begins. What you do, you actually enhance the image first, because the image has to be clear for you to extract the minutiae. So image enhancement is again done by two methods: histogram equalization and Fourier transform. Histogram equalization is basically a method used to expand the pixel value distribution of an image so as to increase the understandable info, to make the info more clear. As seen in this picture, the first picture has the histogram before the histogram equalization, which is basically, all ups and downs, which is not so uniform, which is not so clear, which is little blurred. Whereas the second picture is the one obtained after the histogram equalization, which is, a lot more uniform, which gives, more useful information for the extraction process. It's also done by the Fourier transform method. So what is image binarization? Image binarization is converting the true information extracted from a fingerprint into binary form, along with all the ridges and valleys and all the information, minutiae information. So this binarization is a very important step in the process of ridge extraction. It basically transforms a 256 level image to a 2-level image, which is basically the binary form, that gives the same information in order to make things easy and the process a lot simpler and easier. So in this process, image is divided into 16 blocks, and mean intensity value is calculated for each block. Each pixel is then turned into 1 if its intensity value is larger than the mean intensity value of the current block, which is the present block to which the pixel belongs. So actually the mean intensity is compared, and if the pixel intensity value is larger than that particular mean intensity value, it is assigned a 1 value or else a 0 value. This is how the binarization is done. It has only two values, 0 and 1, as the name implies. So ridge thinning. Ridge thinning is for eliminating the unnecessary pixels till all the ridges are just 1 pixel wide, width of 1 pixel, to simplify things, to reduce the complexity. If there are multiple pixels, you might find it difficult for the further steps, so you just take 1 pixel at a time and you thin the ridge, which is basically eliminating the unnecessary pixels and making sure that it has only 1 pixel wide. Iterative parallel thinking algorithm is used for the ridge thinning process. It's basically single points where there are single ridges or single point breaks in a ridge, which are totally eliminated in this stage. What this algorithm does is just remove all the single point breaks, the breaks and all which the ridge endings and all which abruptly ends, the breaks and all which suddenly ends. It eliminates all this unnecessary redundant information. So this all is considered as processing noise, so we don't want noise, so it removes all the noise. Ridge thinning is used for removing noise. So this is how it looks after the ridge thinning process is done. This is a ridge map, thin ridge map, which has all the unnecessary noise information and all embedded into it, whereas the second one is the image, which is more abstract, more more uniform, which is basically the image obtained after the removal of the hedge breaks and spikes after the ridge thinning process, which is more clear than the initial image. So the results of this project: the input image is enhanced initially with the above mentioned techniques, like image is enhanced using techniques using techniques like this enhancement, using techniques like histogram equalization and Fourier transform. And then ridge thinning is achieved. Ridge thinning is what I told just now. And after that, minutiae are extracted for fingerprints, which is what the basic goal of this project. And also a small region of the output is taken to show the fingerprint clearly. Sometimes you don't need your whole finger to identify the correct match. A part of it is enough, because even the part of your whole fingerprint is unique when compared with a database of images. So this way I modified the code to just focus on a particular area in the whole fingerprint and to match only that particular area with all the other fingerprints. So that way it simplifies things. You don't need the whole fingerprint. Even if the fingerprint is not scanned properly, sometimes a part of it is used to match with the database and to authenticate the person to find the correct identity. Conclusion: this project extracts the fingerprint minutiae for fingerprint recognition. I made some changes to the code to make the fingerprint image look bigger and clear. In such case, it's enough to match that part of image to the database. This way it reduces the complexity, as I told before. So let me run the code before you and show you how all this is done, and let me show you the results practically. So this is the code for the fingerprint minutiae extraction. So initially you read the input image. Here you read the input image, then figure is just to show the print in the form of a picture. After that, binary image is to convert the image to binary form, and after that ridge thinning is done. After that, minutiae is extracted. After that, ridge end finding. The ends of ridges are to be found, so that is achieved by this part of the code. And then the bifurcation finding. Bifurcation is the place where a ridge divides into two. You need that info for the extraction and also for the further steps like matching. So this is the code for that. So let me run this and show you. Here are the results. This is the picture after the whole minutiae are extracted. These tiny things are nothing with the minutiae, which is used for matching in the later stages, which is actually beyond the scope of this project. This project actually deals only with the minutiae extraction. That's what the title says. And these are the individual pictures obtained after every stage. So this is the thinned image, which is obtained after the ridge and thinning is done. It eliminates noise and makes it more uniform when compared to the previous picture, which is picture 2, which is little messed up. So when compared with picture 1, picture 2 is so much clearer, right? So this way it first converts the original image to an input image, which removes the superficial noise, and then after that figure 3, ridge thinning is done, which inherently removes the noise, and then after that the final stage is the extraction of minutiae, where the fingerprint minutiae are extracted. So this is how it is done, and let me modify the code for you and show you a different output. So now here you can see that just a part of the fingerprint is shown. So as I told you before in the presentation, you don't need the whole fingerprint to identify a particular individual, because even a part of the fingerprint is unique from person to person. So even this particular information is enough to match the fingerprints in the database. So this is done by modifying the code. So I also tried the next phase, minutiae matcher, which actually matches the extracted minutiae to a database of fingerprints, which is actually beyond the scope of this project, but I actually tried doing that, but I had a few issues. Let me explain you that. So the issue with the fingerprint matching is actually beyond the scope of this work, but the basic issue is each time a different fingerprint was shown. That should not be the case, but there's some part of the code which is going wrong. It's actually showing the fingerprint, but it's showing a different one each time, which should not work in the real time. So I have to modify the code even a little bit more for that to work completely. And also there is a problem with finding the correct match in the database. That's what I told. Modify the code to match particular fingerprint in the database of fingerprints. So that's what the issue is. So observations, what I observed during the fingerprint matching, which is after the extraction, it used to run different image each time the code is run. Also the input image should be clearly scanned for it to give a match with the fingerprint in the database. If the fingerprint has more noise and more redundant information, it just used to output input image cannot be read. That's what I customized according to my code. So whenever the image is not so clear, it used to just tell that the input image cannot be read. But in the real-time scenario, sometimes the input images may not be clear, may not be good enough to read the whole information inside them, but still the fingerprint has to be matched. So this code should be modified further to properly match the fingerprint, which is anyways beyond the scope of this project. This project is only till extraction of fingerprint minutiae, but out of my curiosity I tried doing the fingerprint matching. Let me show you the code for fingerprint matching which I tried and explain you. Folder E, pattern project, simple fingerprint matching. So let me open this file. Okay, so this is how fingerprint matching is done. You first initially build a database of fingerprints, for you to match a particular fingerprint to that database. So this is building the fingerprint database, and this is building an FMR and FNMR function. After that, enhancement is done to enhance the image, to reduce the noise and redundancies. And after that, you have to mask the fingerprint. You have to put a mask on it, just to identify the particular fingerprint. And after that, the next thing is finding the minutiae, searching the minutiae in the database. And the last stage is filtering the false minutiae. False minutiae are the ones which actually don't help us in finding the correct match, and which sometimes give us the wrong information, which are actually redundant. So those should be removed. And after that, it has to return the minutiae. So building FMR and FNMR. FMR means false match rate and FNMR means false non-match rate. So it has to give the information as to what extent the fingerprint is matching with that particular fingerprint, and how many fingerprints in the database are matching, or maybe matching closely and not matching at all. This kind of information. So after that, it has to get features of arbitrary fingerprint from the template match of the first one. That's what I told you just now. So for each fingerprint template, till what extent it's matching, which is basically called a matching score, has to be calculated in comparison to the first one. So after that, you plot the data. So this is all transform matching data, so which is basically the information which is outputted for you to understand after the transformations. So this is about the fingerprint matching, which is actually beyond the scope of this project, but out of my curiosity, I went a step ahead and I tried to do that, but unfortunately there's some error which is always popping up. So this is my project, and thanks a lot for all your support. Thanks a lot, Professor, and thanks to the TA who patiently answered all our questions and doubts during and before the presentation regarding the softwares and all. Thanks a lot. Without all of you, this project would not have been possible. Thank you.